Well, Algebra 3, this is our video key for lesson 7.3, and that was our lesson on base E and natural logs. Remember E, very popular number in mathematics, that's equal to about 2.718. I recommend you committing that to memory, especially if you're going to be going on to math classes past Algebra 3. And natural log is basically just the logarithm base E. So let's go through, and all the properties and operations, condensing, expanding, all the rules that apply to our regular logarithms regardless of base apply to natural logs. So let's go through some problems here, starting with number 1. In problem number 1, we were asked to rewrite our exponential equation e to the x equals 36. We need to rewrite that into logarithmic form. So we're going to have the log, our base is e, so log base e of 36 equals our exponent is x. Let's remember, we don't write log base e though. Log base e is the natural log, abbreviated ln. So the natural log of 36 equals x. That is our answer for number 1. Number 2, we were asked to write the natural log of x equals 18 into exponential form. So let's remember the natural log, that's a log base e. So our base will be e. Our exponent is what this equals. So it's e to the 18, and that is going to equal x. So that is our answer to number 2. In number 3, we are asked to condense this expression here into a single logarithm. We have that plus sign here, so we're going to use the product property. So we'll have the natural log of 4 times 3x. We can simplify what's going on here. We'll have the natural log of 12x. That is our answer for number 3. Number 4, we are asked to condense this expression into a single log. We have a couple of properties we're going to apply here. Once, because since I see the coefficient out here, I know I'm going to move that inside using the power property, and that's going to become my coefficient. And then because I have a negative sign in here, I know I'm going to use the quotient property. So let's use that power property first. I'm going to get the natural log of a to the 7th minus the natural log of b to the 4th. Now I'm going to use that quotient property, and I'm going to get ln, the natural log of a to the 7th over b to the 4th. And there's my answer for number 4. Number 5, I have the natural log of 2m to the 8th. Remember, since this exponent is inside the parentheses, it only applies to the m. It doesn't apply to this whole expression inside here. If it were to apply to the 2 as well, our exponent would be out here, but it's not. So the exponent only applies to the m. So first thing I'm going to do is I'm going to break this apart using the product rule. So I'm going to have the natural log of 2 plus the natural log of m to the 8th. Now I'm going to use my power property, and I'm going to move this power out into the coefficient spot. So I'm going to have L to the 2 plus 8 ln m. There's my answer for number 5. Number 6, I have the natural log of m to the 5th over n to the 2nd, all raised to the 3rd power. Probably to make things easier, I'm going to go ahead and distribute this power through my parentheses here and rewrite that. So I'll get the natural log of m to the 15th over n to the 6th. Remember, when we're doing a power to a power, we multiply our exponents together. Now, because I have this division here, I'm going to apply my quotient property. So I'm going to have the natural log of m to the 15th minus the natural log of n to the 6th. Now I'm going to apply that power property and move this exponent over into the coefficient position. So I'll have 15 times the natural log of m minus 6 times the natural log of n. And there's my answer for number 6. Number 7, we have the natural log of 9x minus 7 equals the natural log of 5x plus 33. So remember, as long as we have a log with the same base on the left side and the right side, we can set what we have going on in the parentheses equal to each other. So these are both a logarithm base e, so we have the same base. So I'm going to set 9x minus 7 equal to 5x plus 33. Next, I'll go ahead and simplify. That'll give me 4x equals 40, or x equals 10. And there's my answer for number 7. Well, you know what I got to do first? I got to check this, make sure it's a valid answer, not an extraneous solution. So when I plug 10 in here, I get 90 minus 7. That's positive. So I'm good on this side. When I plug 10 in over here, I'll get 50 plus 33. So I'm positive over there as well. So x equals 10 is a valid solution. Number 8, I have the natural log of 4w plus 9 equals 5. So I do just have a single logarithm expression equal to a number, so I'm going to rewrite this in exponential form. So my base is e, my exponent is 5, and that is going to equal 4w plus 9. This is where we're going to use our calculator. If we remember what e equals, that's 2.718. 2.718 to the 5th power equals 4w plus 9. Now we're just going to do some algebra and solve for w. So first, 2.718 raised to the 5th power. It's going to give us 148.336. We're going to subtract 9 from each side, and that equals 4w. So 148.336 minus 9 is 139.336 equals 4w. Dividing both sides by 4, and I will get w equals 34.834. That is my answer for number 8. Real quick, I'm going to pop that back into my original logarithm up here to make sure I don't get a negative inside the parentheses or a 0 inside the parentheses. Well, 4 times 34 and change plus 9, that's obviously a positive number, so this is a valid solution to number 8. Number 9, I have the natural log of k minus the natural log of 14 equals 2. First step is I'm going to have to condense what I got going on the left side over here. So I'm going to end up with natural log of k over 14 equals 2. Now I'll have to rewrite this in exponential form. So I'm going to get e squared equals k over 14, or k is going to equal 14 times e squared. So let's go ahead and do the calculation on the left side there. 2.718 squared equals 7.387 times 14, and I'm looking at k is going to equal 103.425. That'll be my answer for number 9, as long as this doesn't produce an extraneous solution, which when I plug that into my log up here, I do have a positive number, so I'm good. That is a valid solution for number 9. Number 10, we have e raised to the y minus 1 minus 27 equals 54. First thing we need to do is we need to isolate our exponential expression over here on the left. So I'm going to add 27 to both sides. I'll get e to the y minus 1 equals 81. Now I'm going to write this in logarithmic. So I'm going to have the natural log of 81 equals y minus 1. So we'll get out the calculator here. The natural log of 81 equals 4.394. I'm going to add 1 to that to get what y equals. So y is going to equal 5.394. That is my answer for number 10. So hopefully going through all these problems helped you. If you were stuck on anything, hopefully it's got you unstuck. If you're still having some problems on that, please email me. I know as we went through there's going to be some differences in rounding, but as long as you're pretty close to the answer I got up here, you should be comfortable knowing that you know how to work the problem. So again, if you're still having some problems, please email.